Let's now talk about sequences, which mostly means sequences of numbers. There is no grand unified theory of sequences, but there is a bunch of tricks and even some theorems that can be useful not just on the Putnam, but also in research. We're going to see some of these tricks in action on a bunch of example exercises, and you'll see more of them on the homework. So here is the first exercise. Let Q and D be two numbers, let's say real numbers, and let x0, x1, and so on be a sequence of numbers that satisfies the recursive equation xn equals q xn minus 1 plus d for each n at least 1. Find an explicit formula for xn in terms of, now of course in terms of q and d, but we also didn't specify x0, so x0 is another variable. And before we solve this, a couple comments on what's so interesting about the sequences. If you remove the q, this is just a formula for an arithmetic progression. If you remove the d, this is a formula for a geometric progression. So this is a kind of obvious way to merge arithmetic and geometric progressions. Wouldn't it be nice to have a formula that works for both of them? And now you might have seen it in high school, but let me quickly show you how to find such a formula. We just compute the first few values. x0 is just x0. We cannot really simplify it. x1 is qx0 plus d by this recursion. x2 is qx1 plus d, but x1 is qx0 plus d. So q square x0 plus qd plus d. x3 is q times this plus d. Now we can, of course, substitute. And this simplifies to q cube x0 plus q squared d plus qd plus d. And x4, I'm not going to show you this in detail, but here is what comes out. Q to the 4 x0 plus q cube d plus q squared d plus qd plus d. At the latest here, you should see a pattern. So we suspect that xn is q to the n x0. There is always exactly one term with the x0, and the exponent is always this number. And then the terms with the d. And we can factor the d out. So qn minus 1 plus qn minus 2 plus and so on plus 1d. And 1, of course, is q0. And this formula, once you have suspected it, it's completely straightforward to prove by induction on n. If q is not equal to 1, you can simplify this even further. This is q to the n minus 1 over q minus 1 by the geometric series formula, which I think is proved twice in the notes now. If q equals 1, you cannot do this because it would be 0 over 0, so be careful. Either way, this is a non-recursive formula with a dot dot dot, and this is and if q is not 1, you can replace this dot 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 by this fraction, and then you get a non-recursive formula that doesn't even have a dot dot dot. You cannot do any better. You could combine this to q to the n's, but that would not simplify things much. So the upshot is the first ever trick in finding formulas is you compute the first few values and you try to spot a pattern.